Now let's look into the equation of a line which is passing through 2 points, 2 given points. In the last video, we saw 1 point and a line parallel to it, correct? Now here, suppose let's say there are 2 points. Now again, we'll start with the x, y and z axis. This is one more, say this is 0. Say 2 points are there. Say assume that this is one point A, assume that there is one more point B. Okay. Now there is a line which is passing through A to B like this. So, assume that this is the line, some line. There is a line. Now in between, we'll take some arbitrary point P. So we'll join OP. Let's call this as vector R. Okay. Now O to A, and then we have O to B. This is vector B, this is vector A. So what we are doing here, we have OA, this is equal to vector A. Next we have OP, which is vector R, some arbitrary point R. Sorry, arbitrary point P, and the position vector is R. Next we have OB, which is vector B. Now we have vector A, vector B, vector R. Make sense? Now what are we trying to figure out? The equation of the line passing through AB, correct? So point A, call it as x1, y1, z1, and point B is x2, y2 and z2. We have point A and we have point B. Now let's look into the position vectors again. We'll use the same logic what we did in the previous case. Now here vector AP, if you want, see vector AP is what? Vector OP minus vector OA, which basically gives us vector R minus vector A, isn't it? Now what is vector AB? Vector AB becomes vector OB minus vector OA, which gives us B minus A. Now look at the figure. Vector AP and vector AB, they are collinear, isn't it? Because P is a point on AB. Since we know that AP and AB are collinear, since they are collinear, see what we can write is that this one vector AP is equal to lambda into vector AB, where lambda belongs to R, some real number, whatever it might be. Fair enough? So what do we get here? We are going to get R minus A is equal to lambda into B minus A. So make R is equal to A plus lambda into B minus A. This is the formula. R is equal to A plus lambda into B minus A. This formula gives the equation of the line in vector form passing through 2 given points. Fair enough? Now we'll do the same thing for the Cartesian form. That means what if the line is passing through these 2 points? See, x1, y1, z1, x2, y2, z2. Now we'll do that particular derivation. It's very simple. We'll take the same thing, just substitute it. All right. See, what do you have? You have point A, x1, y1, z1, and you have point B, which is x2, comma y2, comma z2. Correct? We have 2 points. Now, point P is some arbitrary point. We'll call it as x, y, and z. Some arbitrary point. We can again use the same thing. That is R is equal to A plus lambda into B minus A. But then instead of that, we'll go back to the previous formula. See, the previous formula what we had was what? X minus x1 by A is equal to y minus y1 by B is equal to z minus z1 by C. But here we can write this A, B and C in terms of x1, x2, y1, y2, y, and then z1, z2. That means here A can be written as x2 minus x1, okay, and B can be written as y2 minus y1. C can be written as z2 minus z1. Now, the reason why we can do it, I'll just show you for one of them, okay, just one. The rest of it is pretty much the same. Now, look at this one. If you take R is equal to A plus lambda into B minus A here. So if I just take the value of x, we have x is equal to x1 for A plus lambda into x2 minus x1. If you make x lambda as the subject of formula, don't you think you will get x minus x1 divided by x2 minus x1? Isn't it the same as A, whatever we have done, whatever we have just done here? That means the final formula for 2 point in the Cartesian form will become x minus x1 by x2 minus x1 is equal to y minus y1 by, y2 minus y1 z minus z1 divided by z2 minus z1. This gives us the formula for 2 point form in the Cartesian form, especially Cartesian form. Okay, and if you want it in the vector form, this is going to give you the answer in the vector form. Now, there is one more thing which I wanted to tell you in the same thing. What if direction cosines are given? Okay, now generally when we talk about direction cosines, we'll get in terms of LMN, correct? For that also we have an equation. Okay, so for that, the equation is going to become x minus x1 by L is equal to y minus y1 by m is equal to z minus z1 divided by n. This is when DCs are given, direction cosines are given. Clear? So, we have learned in the last two videos, we have learned how to find the equation of a line, either parallel to a given vector, parallel to a given line, passing through a point. That is the first type. Second type is passing through two given points. Fine. Now, let's look into the angle between the two lines in the next video.